afternoon, participants. Welcome to our module, okay, on perform effectively with the data analysis. This is a program, okay. What do you understand by data analysis? Interpreting the values, okay, and interpreting whatever observation you are having, right? You will be collecting some information or observation, how you are interpreting, how you are observing it, how you are describing it, how you are interpreting it. Okay. Why we are doing data analysis? Okay, well, what's going on so that we can improve it, right? So, before starting of this session, so you please go through this brief test. There are 5 minutes. You please go through the questions. 8 questions are there, so please answer those. Don't worry if you are not knowing. Okay, you can answer whatever you think. All are multiple choice questions. These questions are based on today's module. Okay. So after the module, you will be getting the same questions once again. please write your name and then. As already discussed, data analysis will help you to analyze the trend, what is happening in the industry, what is happening in your institution, what is happening in your clinic or with your patients. Okay, so you can understand the, observe the happenings and understand the trend. Based on that, you can improve the quality of your work. You can improve the treatment, you can improve the quality, okay? And you can evaluate if the changes are making better outcome or not. What is outcome? Outcome may be different in different industries. In a healthcare industry means patient satisfaction or patient care. Better patient care is the outcome. If in an industry, better profit will be the outcome. Okay, understood. Data analysis improves the quality of process and outcome. What is the process? Daily, what we are doing. That we can improve based on the data analysis. Okay. Our program is on data analysis. Okay. These are the objectives of the program. Identify the current trends. Okay. Using data analysis methods. Okay. There are so many methods to describe the data or describe the observation. Okay. Based on that, you can identify the current trends and you can identify analysis tools. Tools can be software. You can use an appropriate software. You can use appropriate statistical methods. Both are tools. Understand? You can use right analysis tools. Then develop an action plan. Okay, you are working in a clinic or a hospital and you are observing that some area is having some defect. What will be the action plan? How you will improve based on the observation. You are observing that patient satisfaction is poor. Then what analysis you will do? You will look for the factors. What factors are affecting patient satisfaction? Right? You identified that doctors are very rude to patients, or nurses are very unkind to patients. So what will be your action plan? You identified that. Yeah, what you will do? Yeah, solve it, right? So solution, that is the action plan. So observe the data, understand the trend, then identify the tools. Tools means which software you can use or which statistical method you can use. Then identify the factors. Then you use the action plan to improve. Okay, these are the three things. These are the program objectives. Okay. And you know, in this program, all of you know, we are having 8 modules. Okay. 8 modules will be completed in 2 days. Okay. Today, we will be going through module 1. Module 1 is the first module. What is that? discovering basic statistics. After that, we will be going through module 5, that is using of parametric tests. Okay, so we will understand both modules today. Module 1, okay, this is module 1, so we will go through this. These are the various contents of module 1. Define basic terms in biostatistics. What are the commonly used terms? Okay. Then types of data. What are the types of data? Okay. What are the scales of measurement? Scales of measurement means you told before that we are observing the values, right? Not all values are measured in same scale. Some will be categorical, some will be continuous. Understood? Some will be numerical, some will be non-numerical, nominal, ordinal, like that. All these things we will see. Okay, then importance of biostatistics in health research. So you are studying the tool. What is the tool? Biostatistics. And you will be using what tests can be used, what software can be used, how we can use it in research. Okay, these things we will cover in the module 1. Okay. Okay. What do you understand by the term biostatistics? What is the term statistics? Yes. Collection of data, right? Collection of data, compilation of data. Compilation of data means you are collecting the data and compiling in a, how you usually compile in Excel or SPSS or some software, you will compile the data. Then analyze the data. Just data is there. You have to look and analyze it. What is the problem? What is the trend? And what are the factors affecting the outcome? Understood? After analyzing, what is that? Interpret. Okay, you have to apply your thinking. How to interpret the data. Then what is that? You have to use that finding to improve the function. Okay, understand? You have to improve the function. So, statistical process and methods applied to collection, compilation, analysis and interpretation of biological data. Okay, that is known as biostatistics. Okay, you can apply statistics in any field. You can apply in business, you can apply in marketing, you can apply in data science, understood? You can apply in health also. You are all health professionals, okay? So you are applying in health field. Then it is known as biostatistics. Understood? Very clear, right? I was telling the term data always, right? What do you understand by data? Loudly, again. Yeah, observation, information. Okay. Values of qualitative and quantitative variable. What do you understand by qualitative? What do you understand by quantitative?
Quantitative numbers.
Yeah.
Measure.
Yes. Quantitative means quantity. You are measuring, right? Some numbers are there. You are measuring it using a scale. That is quantitative. What do you understand by qualitative?
It's like good, bad, good.
Yeah, good, bad, poor, all are categorical, right? Poor, good, true or false, live or alive, live or dead, male or female, all these are qualitative. You are categorizing based on some quality. Understand? Quantitative means quantity, measuring. Okay. So, Data are set of values of variables. Okay. Based on object or person. Okay. Data is singular or plural? Yeah, data is plural. What is the singular of data? Tell me. Datum. D-A-T-U-M. Not dato. Okay. Datum is the singular. Data is plural. Data means observation, multiple observation. That is data. Okay. Single observation is data. It can be about quantitative variable or qualitative variable. Observations. Okay, different observation. Okay, now we will come to two more terms. Descriptive statistic and inferential statistics. Okay, what do you understand by descriptive statistic?
Descriptive statistics is like just saying how many people are being disobeying.
Yeah, you are describing about the data. Whatever data you are having, you are describing about it. That is descriptive statistics. What do you understand by inferential statistics? Inferential means you will be inferring the finding to a population. You are collecting the data from a sample, you are inferring it to a population, or you are generalizing to a population. That type of statistical method is known as inferential statistics. So descriptive statistics help to describe, show, or summarize the data. Okay, that is describe. How we summarize? By diagrams or tables or some values. Understand? Two type of measures are there. Measure of central tendency, measure of dispersion. Measure of central tendency means like a mean, median, mode, and all. Measure of dispersion means how each value differs from the central value. Okay, understood? So measure of central tendency will be there in descriptive statistics. Measure of dispersion also will be there. That's why when you are doing analysis, you will calculate mean and the standard deviation, or median and interquartile range. Median is the measure of central tendency. Interquartile range is the measure of dispersion. Okay. Now, these are the things. Measure of central tendency are there, measure of dispersion are there. Can you read out what are the measure of central tendency? Yeah, mean, median, and mode. Measure of dispersion, or measure of variability. Range, interquartile range, and the standard deviation. These are the measures we use in descriptive statistics. Understood? Inferential statistics. We already mentioned. Inferential statistics means we are inferring the finding to the population, or we are generalizing the finding to the population. Okay, so there are so many techniques used. What are the two common methods used? Parametric tests and non-parametric tests. Okay, two type of tests are there for generalizing the finding to the population. Understood? Okay, two type of tests are there: parametric statistical test and non-parametric statistical test. Is it clear? Now we will look at different types of data. Okay, what are the two type of data that we know? Numerical data. What do you understand by numerical data? numbers, right? Numerical data, numbers. What is the opposite of numerical data, you know? Categorical data. Okay, numerical data, categorical data. Numerical data can be of two types. Continuous data or discrete data. Continuous data, no? On a continuous scale. Okay. So like, can you give some example of continuous data? Age. Okay, very good. Height, weight, age. Okay. If you are working in a clinic, you are measuring systolic blood pressure, diastolic blood pressure. All these come under continuous data. Discrete data, no? Okay. Number of people attending an institution, or number of people attending a clinic, number of students attending a class. All these are numbers. They are counted. They are known as discrete variables. Okay. So please remember, continuous variables are measured, discrete variables are counted. Okay. Can you remember that? Continuous and discrete. Okay. Okay, participants, you can keep this learning low. Okay. So you can jot down the points. Whatever you are learning related to biostatistics, data, or any information in module 1, you can note down. Okay. So, continuous data, I told you, continuous are measured on a continuous scale. Discrete data are counted. Number of patients, number of doctors, number of students, number of teachers, okay, or number of shops in a street. That is also discrete, right? Categorical data can be two types. Categorical data can be nominal or ordinal. Nominal means gender can be arranged as male or female. Okay, there is no order in presentation. We cannot say that male is higher than female. Both are equal. So, gender is a nominal variable. Another one. Okay, you are working in a clinic and the patients are, you are working in a palliative care clinic. So patients are coming there and you are grading pain of the patient. How you are grading pain? Grade 1, grade 2, grade 3, grade 4, like that. Otherwise, normal, no pain, mild pain, moderate pain, severe pain. Understood? You are grading it. So there is an order. That type of data is known as ordinal data. Understood? Order of presentation. Another example. Staging of tumor. You know stage 0, stage 1, stage 2, stage 3, stage 4. There is an order. Stage 0 means confined to the organ. Okay. Stage 1 means slight distension is there. Stage 4 means metastasis is there. Understood? So staging of tumor is also ordinal. Another one. You are giving assessment to teacher. Okay. Very boring or very good. Okay. Very boring means 1. Boring means 2. Neutral. Not boring, not good. So that's 3. 4 means good. 5 means very good. Understood? So you are giving 1, 2, 3, 4, 5. That type of scale is known as Likert scale. Have you heard of that? Likert. Likert. That type of scale. Strongly disagree, disagree, neutral, agree, strongly agree. Got that? That is also ordinal. So can you give some example of ordinal? Yeah, this Likert scale in the order. Another one, staging of humor. Then pain, grading of pain. All these are ordinal, right?
Yes.
So now we will go to next one. Qualitative data and quantitative data. What is qualitative data? I told you, based on quality we are categorizing, right? Qualitative data that cannot be expressed as a number. So we are categorizing it. Okay. Are you able to see this slide? Quantitative data means expressed as a number and quantified. Okay. It can be counted or measured. When it is counted, it is known as discrete data. When it is measured, it is known as continuous data. Got it? Then, two other type of data is there. Primary data, secondary data. What is the difference between primary data and secondary data? Yeah, data collected directly by the researcher. You are going to a place and you are collecting data directly. That is primary data. What is example of secondary data?
Publication.
Yeah, publication or maybe from website, statistics website, census website. You are downloading the data. That is already collected by some other person. We are downloading from that. Understood? That is secondary data. So, what are the method of primary data collection? Survey, very good. Yeah, questionnaire. Yeah, interview. Okay, all these are method. Focus group. Focus group means you will be having some groups of people and you are asking some questions. So they will give the answer. Understand? Then what else? Social media monitoring. What is that? You are giving a survey in Facebook, Instagram, or some other YouTube. Okay, you are giving some survey and you are getting back the answer. Okay, all this. Huh? Then, secondary data. Government statistics, associations, website. Okay, publications. As you told us, publications comes under secondary data. So, got that idea, right? Now, nominal I told you, nominal and ordinal are two type of scale of measurements. Nominal means just by name, good, bad, male, female, alive or dead. Okay, like that. These are all nominal information. Gender, male, female. Okay, occupation, maybe professional, government employee, unemployed, or self-employed. These are all nominal. Okay. Ordinal means order is important. Stage of humor, grade of pain. Okay, all these things. Interval. Interval and the ratio are continuous variables. Okay, continuous variable. Why it is known as interval? You know, the unit is same. Okay. Proportionate interval between variables. Okay, understand. Proportionate interval between variables. So, if you are taking temperature, the interval between 35 degrees Celsius and 30 degrees Celsius is 5, right? That will be same like 35 to 40. Okay, 30 to 35 interval will be same like 35 to 40. That interval will be same like 40 to 40. Understood? Interval between variables will be measurable using a unit. But temperature, you cannot say that today's temperature is double the temperature of last week. Can you say that? Why it is not possible?
Don't have a scale.
Yeah, we don't have a zero value. Understood? We cannot say that 0 degrees Celsius is absolute zero. We cannot say that. Okay, maybe some other place may be having minus 10 degrees Celsius. Some other place may be having minus 40 degrees Celsius. Understood? So there is no absolute zero. In interval scale of measurement, there is no absolute zero. So we cannot say that temperature of today is double the temperature of yesterday. We cannot say that because there is no absolute zero. But it is having a sister, and the sister is half the height of that. Okay, so we can say that. Why we can say that? Because there is a absolute zero. Absolute zero is there. Nobody can have height minus 10. You cannot, right? So both are having absolute zero. So one person's height can be double the height of another person. That type of variable is known as ratio scale. So nominal, ordinal, both are categorical. Interval, you think about temperature. Okay? Systolic blood pressure also interval. We cannot say that, hey, my systolic blood pressure is double the systolic blood pressure of another person. Can we say that? Why? There is no absolute zero. When my systolic blood pressure is zero, no? I am God. Understood? So we cannot say that. So systolic blood pressure is interval scale. Okay? Got that point? Height, weight also ratio. Why? There is no, oh, my weight is becoming minus value nowadays. We cannot say that, right? Nobody can have weight minus 10 kilogram. It will be 110 or 80 or 90 or like that. Understand? So these are the different scales of measurement. Okay. Now, categorical variables can be nominal or ordinal. Okay, nominal variable means, just name, nationality or favorite animal, all these are nominal. Okay, but if order of data is important, it will become ordinal variable. Understood? Grading of pain, staging of tumor, or Likert scale. Okay, you think about teachers. Very boring or very good? Okay, that's the Likert scale. Then, interval variable means there is no zero value, no absolute zero. Think about temperature. There is no absolute zero. That's an example of interval scale. Then the ratio scale means there is absolute zero is there. Okay. What are the importance? In sampling method or sample size calculation, we can use biostatistics. Okay. When you are collecting a sample should be representative of the population, right? So we have to apply some statistical method to collect the sample. Okay. Then, calculating sample size. When you calculate sample size, you have to put some alpha error value, beta error value, power value and all. Those all are calculated based on statistics. Okay, so these are the things. To get a sample which is representative of the population, you need statistics. To calculate adequate number of sample size also, you need statistics. Okay, understood? Then, describing the data. I told you, what are the two things in describing data? maybe measure of central tendency and measure of dispersion. Okay, both are statistics. Okay, we need, that is the importance of statistics in describing the data. Then comes influential statistics. You are generalizing the finding in your sample to the population. There also you need biostatistics. Okay, these are the various uses of biostatistics. Now I will ask you some questions. Okay. Yes. Data from government websites is an example of secondary data. Okay, very good. I'm so happy that you are listening. You understood. In the scale of measurement, order of presentation is important. Ordinal. Okay, very good. Ordinal means order of presentation is very important. What is the third question? This measure is used to generalize the finding from a sample to the population. Inferential statistics. Okay, so you understood three major points. Okay, you know about secondary data and primary data. You know about ordinal measurement, then inferential statistics and descriptive statistics. Okay. Now we can go to conclusion. Okay. Conclusion part, one part is question and answer. You answered correctly. Can you give one point related to the learning log? Can you give one point related to biostatistics? Yeah, applying the principles of statistics to biological or health science. What are the principles of statistics? Can anyone say? Yeah. So collect data, compile data, analyze data. After that, interpret. Okay. So collect, compile, analyze and interpret the data. That is a biostatistics. You are applying it to biological specimens or biological science. Okay. Can you tell something about data and the types of data? Primary data and secondary data. Yes, please. Any other type? Qualitative, quantitative. Can you please tell me what is qualitative, what is quantitative?
Quantitative is the word we check quantity of the.
Yeah, quantity. Or you can measure means it's quantitative data, right? Qualitative data means not measurable. You have to arrange in some categories, right? Qualitative data. Any other type of data? What are the two types of numerical data? Can anyone say? No? Discrete data and continuous data. What do you understand by discrete data? Yeah, counted. Discrete data can be counted. Can you please give any example of discrete data? Yeah, number of cards. Oh, yeah, she likes cards. Number of cards. Huh? Oh, number of girls. Wow, very good. Then what else? Number of students in a class, number of teachers in a college. All these are numbers, right? All are discrete variable. Continuous variable. Can you give some example? Height, weight, maybe something like hemoglobin value, blood sugar value, blood pressure value, all these things, right? Then comes scales of measurement. What are the scales of measurement? Can you remember one scale of measurement? Nominal. Yeah, nominal. Can you give some example of nominal? gender, occupation, all these things, right? Okay. So then, importance of statistics. Can you give some importance of statistics? Why you are learning statistics?
And use it to calculate sample size.
Oh, calculate sample size, very good. Then,
We can use it for inferential statistics.
yeah, inferential statistics, so that you can generalize. No, what is inferential statistics? Can anyone say?
Use the sample to generalize it, to generalize the population.
Yeah, finding from the sample can be generalized to the population. That is inferential statistics. So all the areas you were able to understand, and so I will check. Activity we debrief, and as I told you before, okay, you can please answer this. This module 1. Please write your name also. Yes, please. Yeah, this is only for module 1. Almost module. So sorry. So sorry. What are they? So all of you got module 1 assessment, right? Huh? Grade of pain, ordinal, and sometimes ordinal can be interval also. If the grade is same, oh, interval should be measurable. Can you measure exactly that grade of pain between 1 and 2 is exactly same like 2 and 3? We cannot, right? Grade of pain we cannot measure exactly. The difference is not same. So it is ordinal. Okay. Understood. If the measurement is exactly measurable, it can be interval. Got that? Yes, right there, me. Okay, now we finished module 1. Okay. First module finished. Now next you can
I go to I go to
continuous. Huh? Okay. Okay. Now we are coming to the conclusion of module 1. Okay, we understood how important the understanding of biostatistics, how important the understanding of terms, understanding of data, type of data, and the type of statistical analysis, and how we can use it in our health science research or in our own profession. Sometimes can be in industry also we can apply it. Okay, these are the various books. Okay, discovering statistics using SPSS. So you can learn. Second is biostatistics. Third is one book. It is co-written by me also. Okay, so you can go through it. Simply, yeah.
You did.
Oh, nice. Okay. So then, now we will go to the second module. Okay. Second module is using parametric tests. Okay. So first you understood about the basic biostatistics. Now we will go to parametric tests. Before going to the session, what is your understanding about parametric tests? Yes. What do you understand by parametric tests? Yes, please. Anything okay? You know? Specific statistical test. Okay, very good. A specific statistical test. Why we are applying statistical test? Yeah.
Because the data collected is normally distributed.
Okay. Parametric test is applied when data collected is normally distributed. That's a good finding. Then why we are doing it? Why we are applying this statistical test? Yeah, inferential statistics, right? So as in previous module we learned, we can generalize the finding of the sample to the population. So it is an inferential statistics, right? So you are telling that parametric test is applied when data is normally distributed and when it is a method of inferential statistics. Okay. So these are the contents of parametric test. This using parametric test, this module, these are the contents. What are the contents? One is applying one sample t-test, independent sample t-test, okay, paired sample t-test, and one way ANOVA test. These are the four tests which we use for inferential statistics when we are doing parametric tests. Understood? Okay. So two type of tests are there, parametric test and non-parametric test. These are used as a part of inferential statistics. Understood? Parametric test is used when data is normally distributed. Non-parametric test is used when data is not normally distributed. Please remember that. Parametric, normally distributed data. Non-parametric, not normally distributed data. And another assumption is that there should be equality of variance. Okay, I will give you the study law, so you can note down the points. You can note down the points in this learning log. Okay. So as we know, when data is normally distributed and when there is equality of variance. Variance means what? What do you understand by variance? How the data varies from the central value. Okay, it is the square of standard deviation. Okay, all of you know about standard deviation, right? Square of standard deviation is known as variance. Understand? So it's when there is equality of variance only, we can apply parametric test. When there is no equality of variance, you have to go for non-parametric test. Okay? And the sample size also very important. You can use parametric test when sample size is more than 30. Okay. When sample size is less than 30, go for non-parametric test. Okay. These are the various parametric tests. As already we saw, one sample t-test, independent sample t-test, paired sample t-test, and a one-way ANOVA test. Okay. So first we will see one sample t-test. So these four things will be covered now. One is that when to use it, and what are the assumptions of using one sample t-test. How to do it? Okay, this is a learning by doing. Okay, how to do it and how to do by yourself. So what is happening now? I will tell you when to use it. I will tell you what are the assumptions also. I will tell you. After that, I will show you the steps how to do it. Then you please do after that. Okay. So what is one sample t-test? You know, we have to check, is there any difference between the sample value with the population value? Okay, so you are having a data, right? So you are having a sample of 100 people. You are having systolic blood pressure values of 100 people. So you want to know if the mean systolic blood pressure value is different from a standard value. Standard value you can get from textbook or you can get from some guideline. Understood? So that is one sample t-test. Compare mean value of a dependent variable in the sample with the standard value of population value. I will give an example. I am having data about 100 people and the mean systolic blood pressure value is 130. So I want to know if it is significantly different from standard value. Standard value is 120. So I am checking if 130 significantly different from 120. Got that? So that then we can use one sample t-test. What are the assumptions? As Fatin told earlier, data should be normally distributed. That is one assumption for one sample t-test. Okay. Dependent variable should be numerical also. What type of numerical? Can be interval scale or ratio scale. Interval scale means that interval will be exactly measurable. Okay, difference between 35 degree to 40 degree is same like difference between 40 to 45. Understand? That's the interval scale. Okay. Ratio scale means height of a person is double the height of another person. Both are having absolute zero value. Understood? So that's an interval scale or ratio scale. It should be. Then data should be normally distributed. And data collected from a representative sample, not a biased sample. What is biased sample, Yeah. Your name? Pong. Yeah, Pong got data from people in Ipoh. So what he does, okay, very difficult now. I am going for tea. Then I will ask 3 people there. Then, I want to eat some mee goreng. So he is going to another restaurant. So he will collect some data from there. Is that a representative sample? No, right? It is a biased sample. So to apply one sample t-test, data should be collected from representative sample. Okay. Yeah, another person is going everywhere. Okay, going to different places in Ipoh and collect data from different places, making sure that it is a representative sample. Okay, so that data we can apply on sample t-test. Okay, got that. Okay. This is the exercise for today. Compare mean systolic blood pressure value in the sample with the standard value. Standard value is 120 millimeter of mercury. Okay. So, I am opening the data file. Okay. All of you please observe the data file. You can open your Gmail to download the data file. So, there are so many variables here, right? Age is there, gender, department, systolic blood pressure before treatment, systolic blood pressure after treatment, fasting blood sugar before treatment, fasting blood sugar after treatment. So many values, so many variables are there. Now, what is the aim, of this exercise? We have to check if the mean value of systolic blood pressure is significantly different from 120, because 120 is the standard value. Okay. So how to do that? You have to click on Analyze and you have to click Compare Means. Because we are actually taking the option Compare Means. Because it's a parametric test, right? So you have to click on Compare Means. It will show all the parametric tests. One sample t-test, independent sample t-test, paired sample t-test, and one-way ANOVA. Okay? All of you got that? Then you have to click on one sample t-test. When you click one sample t-test, you will get 2 options. You have to select test variable and you have to select test value. Test variable, you have to select the variable which you are testing. Here it is systolic blood pressure before treatment. SPPBT, that is systolic blood pressure before treatment. I am just moving to test variable and just transferring that variable. Okay. Then test value, I am just typing 120 because we are checking if mean systolic blood pressure value is significantly different from 120 or not. Okay, got that? Then you have to click the options. What are the options? This options you have to choose confidence interval 95%. Okay, that's the option we are choosing. Then click continue and click OK. So what are the steps we are doing? First we selected systolic blood pressure before treatment and moved to test variable and typed 120 as test value. Then click options, then selected 95% confidence interval, then continue, then click OK. Okay? So this is a simple method. Huh? Got that clear? So what are findings we are getting? Systolic blood pressure before treatment. What is the N? N is the sample size. Okay, mean value is 136.46. Again, you got it? Oh, okay. So you can download that file. Oh, okay. All of this got. So you would like to use another computer? Yeah, you can. You maybe download it. Okay. Double click on that. It will take some time. What about you guys? So we got that mean value of systolic blood pressure before treatment is 136.46. Understood? And standard deviation is 8.051. But we have to look at one sample test. One sample test means it will be showing test value. Test value is 120. We are checking that if the mean value 136 is significantly different from 120. Okay, is it significantly different? You have to look at the SIG value. Significant two-tailed. Have you seen that? Second, third value. Significant two-tailed is 0.000. Okay. If the significance value is less than 0.05, if it is less than 0.05, it is statistically significant. The difference is statistically significant. Understood? Now, I will show you one more example. Okay. So, systolic blood pressure, we will check if it is significantly different from 140. Okay. So, how to do that? Analyze. This could be compare mean. One sample t-test. Yeah. Now you have to click reset. When you click reset, all the values will be to the default initial state. When you click reset, got that? Vignesh, you got that? Now you have to select systolic blood pressure before treatment, move to test variable, and the test value you put as 140. All of you are doing with me? Yeah, 140. Then options. You please select confidence interval 95%. Okay? Then continue. Then click OK. So what is the finding now? It is still significantly different, right? But the significance value is less than 0.05. So it is significantly different. Okay, how to interpret the mean value of this sample is significantly different from the test value. Okay, so that's you are able to open now? No. Maybe that computer, some computer may be lagging. Yeah, it's on. Okay guys, so one content of this module is finished. Now we will go to next content. using independent sample t-test. First test name was one sample t-test. Okay, that means only one sample was there. Right. Value from one sample we were comparing with standard value. Understood? What will be independent sample t-test? Yeah, two samples are there, both are independent to each other. Understood? Then only we are applying independent sample t-test. What are the assumptions? Assumptions will be same. Data should be normally distributed. Then what is the second assumption? There is equal variance. Variance should be equal in two groups. Okay. Then what is the third assumption? Yeah, numerical. It should be numerical, either ordinal, either interval or ratio. Then what is the other assumption? Yeah, more than 30 sample size should be there. Okay, very good. More than 30 sample size, normally distributed, equal variance should be there, and the data should be collected from representative sample. That's important. These are the assumptions. Data should be collected from a representative sample, normally distributed, equal variance, sample size should be more than 30. Okay. Okay, very good. Then, compare means of two independent variables. Okay. Values of dependent numerical variables in two groups. Those two groups should be independent to each other, not related to each other. Understood? So, compare mean values of two groups which are independent to each other or not related to each other. Can you give some example of two independent groups? Male and female. Any other?
Date online.
Huh?
Date online.
They don't arrive. But no, you please select two groups which are alike. Male and female. Well, educated group and a not educated group. Employed group, not employed group. Different groups we can select. Okay. Year 1 students with year 2 students. Both are independent to each other, right? So we can choose that. Assumptions. Dependent variable should be numerical, can be interval or ratio scale. Understood? Then data is normally distributed and the data collected from representative samples. Okay, so make sure that your data is collected from representative samples. Got that? Okay, this is the exercise. Compare mean systolic blood pressure value among males with the females. So, systolic blood pressure value among males is compared with systolic blood pressure value of females. Okay, can we do that exercise? Are you able to open? Now you can check. Systolic blood pressure value is there, no? SPPBT. That is systolic blood pressure before treatment. We want to know if the mean systolic blood pressure value among males is different from females. Understand? So in this data file, male and female are coded as 1 and 2. 1 as male and 2 as female. Okay? How to do that? You have to click on Analyze, Compare Means, Independent Sample T-Test. Okay? Did you get this step? Okay, once more I will tell you. Analyze, Compare Means, Independent Sample T-Test. Now, you have to select the test variable and you have to select the grouping variable. What is test variable? It will be systolic blood pressure. Grouping variable will be gender. Understood? Very easy. Okay, systolic blood pressure before treatment is the test variable. Grouping variable is gender. Okay. When I selected gender as grouping variable, computer got confused. It is showing 2 question marks. Got confused. How the groups? Yeah, how to select the groups? We have to define it. How to define? You have to click on define groups. Okay, got that? When you click define group, group 1 you give us 1, group 2 as 2. Why we are giving 1 and 2, you know? Because I gave the number 1 for male, 2 for female. If you type male and female means you have to give group 1 will be male, group 2 will be female. Got that? Now click continue. Okay. Here also you have to click options. Yeah, please click 95% confidence interval. Got that? Then click continue. Then click OK. So you know. So here one problem is there. So this one, systolic blood pressure before treatment among males, mean value is 138. Among female, mean value is 135. So the difference is not very much, right? But you have to look at independent samples test. It will show 2 type of tests. One is Levin's test of equality of variance. Second one is t-test for equality of variance. First, you have to look at Levin's test of equality of variance. Why? Equality of variance is a must to do independent sample t-test. Got that? So here, Levin's test of equality of variance, you have to look at the significance value. Okay, significance value means it is another name for p-value. Okay, got that. SPSS will not give the p-value word. Instead of that, they will give significance value, SIG value. But it is a bit tricky. If significance value for Levin's test is more than 0.05, equal variance is there. If it is less than 0.05, no equal variance. Understood? Here, it is less than 0.05. So, no equal variance. Got that? Why not equal variance, you know? It's a cooked up data. I tried to modify the data. If I have taken the real data, the data may be different, right? So, you have to look at that. Huh? So, this one, significance value is less than 0.05. So, equal variance not assumed. So, please look at equal variance not assumed. The lower line. Have you seen that? Lower line. Look for the significance value. What is the significance value here? 0.029. Okay, that means difference between male and female is statistically significant. Why it is statistically significant? Significance value for t-test is less than 0.0. Okay, but you have to look at equal variance not assumed. Why? Levin's test significance value is less than 0.05. Okay, if Levin's test significant value is more than 0.05, you have to look at the upper. Got that? Is it clear? A bit confusing? I will show you one more example. No need that. Okay, this one, So you have to upline is equal variance assumed. If equal variance assumed, you have to look at the significance value of upper line. That is 0.035. That is the significance value. If equal variance not assumed, you have to look at the significance value of lower line. 0.029. Okay, got that? How to choose that? You have to look at Levin's test significance value. If Levin's test significance value more than 0.05, equal variance assumed. If less than 0.05, equal variance not assumed. Okay? Can you please do systolic blood pressure after treatment among male and female? Can you do that? Anyone volunteer and help others? Okay, please tell the steps. Who will volunteer? Yeah, now Victor is sitting looking down. Can you volunteer? Please tell the steps.
That's all.
Yeah, how to do independent sample t-test. Now the aim is systolic blood pressure after treatment among male and female.
Analyze.
Okay,
Compare.
okay, very good.
Independent sample test.
Okay, very good.
And then put the
Now I will reset it. Now can you tell me?
reset.
Yeah.
And
Then
then put SBP 80
SBP80 as test variable.
as variable.
Okay,
Grouping is gender.
okay, very good.
Then put define group.
Yeah, define group.
Group 1 is 1, group 2 is 2.
Okay, group 1 is 1, group 2 is 2.
Then press option for the thing.
Yeah, continue.
Continue. Then press OK.
Options. Oh no, options. You have to check 95% confidence interval. That is automatically selected. Because why if you are doing a laboratory based study, many times you have to choose 99% confidence interval. So you have to go to options and change from 95 to 99. Got that? Otherwise, community based studies 95 is enough. Okay.
Alright.
Then click OK. Yeah. Can you please interpret the finding? Which one you will choose? Equal variance assumed or not assumed? Assumed. Because Levin's test of equality of variance, significance value is more than 0.05. So you can assume equal variance. Then which value you will look? Yeah, upper one, that is 0.299. Is it significant or not? Not significant. Why it is not significant? More than 0.05. Very good, very good. Now you learn independent sample t-test. Okay. Now we will go to next test. Okay. As I promised you, promised you before, I will give you some snacks. Okay? Yeah, 3 for you. And each one can take 3. Okay. I know you maybe I put like this now. Okay.
Thank you. Thank you.
Okay, friends, we can go to the next one, right?
Yeah.
Next test is paired sample t-test. Paired sample t-test, you look at this diagram. Okay, same sample at two different times. You are comparing the same sample at two different times. One example I will tell you, you are working in a clinic. You are diagnosing 20 people with diabetes. Okay, what is the blood sugar value at that time? Then you are starting treatment. After 6 months of treatment, what is the blood sugar value? So you can compare before and after treatment. Another one, I am giving a lecture. Before lecture, what is the knowledge level of students? After lecture, what is the knowledge level of students? So I can use it, compare. Okay, that is an example of paired sample. Paired sample means same sample at a two different frame of time. Okay, time frame, 2 points in time. Okay. So when to use, you understood? Okay. Compare mean value of dependent numerical variable in a group between 2 points in time. Okay. Before and after an intervention, before and after a treatment, like that. Understood? So, what are the assumptions? Same. Dependent variable should be numerical variable. And what type of numerical variable should be interval or ratio scale? Understood? And the data should be normally distributed in both groups. That's the one thing. Okay. Normally distributed and data collected from representative sample. So, make sure that you are collecting representative sample, not biased sample. Understood? Okay, this is an example. In our data file now, we have two data, systolic blood pressure before treatment and the systolic blood pressure after treatment. When you are using, you want to compare the mean value before treatment with the mean value after treatment, you can use paired sample t-test. If data is normally distributed. If data is not normally distributed, you have to look for non-parametric test. So can we do the test now?
Yes.
Okay, I am opening the data file. Okay. Two variables are there, systolic blood pressure before treatment, systolic blood pressure after treatment. So, paired variable means, what is the other requirement, each person should have two different values. Okay, same person should have two values. If one person is not having two values, only one value is there, he will be excluded of the analysis. Okay, understood? If 10 patients are there, 9 patients have before and after value, one patient have only before value, then that 10th patient will be excluded from the analysis. Understood? That's one requirement. Yes, please.
Before and after that is the same. Is it okay?
Yeah, okay. We have this test, we have testing the mean value of 20 people before with the mean value of same 20 people after. Then we are checking. Some of the values may be same, some of the values may be lower, some of the values may be higher. Understood? So what is the step? You know, analyze, compare mean. Okay. Paired sample t-test. Okay. When you click paired sample t-test, they will ask for variable 1, variable 2, which is a pair samples. One variable 1 you have to select one variable, variable 2 will be second variable. Okay. Here I am selecting systolic blood pressure before treatment as variable 1. And once again I am selecting systolic blood pressure after treatment. It will go as variable 2. Understood? Then I am clicking options. Options 95% confidence interval. Continue and I click OK. Okay. So please check. Systolic blood pressure before treatment. What is the mean value? Mean value is 136.46. Systolic blood pressure after treatment is 127.7. Understood? So the difference. Yeah, you can look for the paired sample test. Okay. What is the difference? Paired difference. 8.716. What is the meaning of 8.716? That is the difference between systolic blood pressure before treatment, mean value of systolic blood pressure before treatment and systolic blood pressure after treatment. Difference is 8.7. Okay. You have to look at 95% confidence interval of difference. What is 95% confidence interval of difference? That means if you repeat this study 100 times, 95% time the difference will be between these two values. Understood? If you repeat this study 100 times, 95% of times the difference will be between these two values. Which are these two values? 8.212 and 9.222. Sometimes difference can be 8.2, sometimes difference can be 9.2. Understood? What do you think? Most of the time, the systolic blood pressure before treatment will be higher than systolic blood pressure after treatment, right? So you have to look at significance value. What is the significance value here? 0.000. That means less than 0.001. Okay, you have to interpret like that. It is less than 0.001. Okay, because SPSS will show only 3 digits. That's why it is showing 000. There may be 0.00001 or something. Okay, that we don't know. Got that? So it is significant. How you will interpret this finding? How you will interpret this finding? Oh, the difference between systolic blood pressure before treatment and after treatment is statistically significant. One way we can say, you can look at the 95% confidence interval of difference also. If 95% confidence interval of difference does not include 0, that means it is statistically significant. Okay, if 95% confidence interval of difference does not include 0. 0 means what? There is no difference. You told before, right? Both the same value means it will be 0. So, does not include 0 means there is always significant difference. Okay. Now, can you do the the difference between fasting blood sugar before treatment and the fasting blood sugar after treatment, if it is significant or not. Can anyone volunteer telling out loud and helping your friends? Picnic. Please volunteer. Analyze, compare means, sample titers, very good. Now you can click reset. Reset means it will go to previous one. Now, which one you will choose now? Fasting blood sugar. Yeah. Yeah. FBS BP selected. Then second one, FBS option 95%. Continue. Okay. Now you check. Is it significant? Yes, it's significant, right? So, fasting blood sugar before treatment and after treatment, the mean difference is 17.18. That means difference is very big. Okay, and you have to look at 95% confidence interval of difference. Okay, what is the 95% confidence interval of difference here? Lower value is 13.28 and upper value is 21 point something. Huh? So that means it is not including 0, right? I am just giving an example. Instead of 13 and 21, it was minus 10 and plus 10. Then will that be significant? Minus 10 to plus 10. So that means it includes 0. Then it will not be significant. Understood? So if the 95% confidence interval value includes 0, it is not significant. If it is not including 0, it will be significant. So please keep in mind. Sometimes you are taking printout, you are not seeing significant value also. By looking at 95% confidence interval value, you can check if it is significant or not. Is it clear? Now we will go to next exercise. One way ANOVA test. Okay, ANOVA. Can anyone say the full form of ANOVA? Analysis of variance. Okay, analysis of variance. So we are, what is the requirement, you know? One sample titers. How many samples were there? One sample. So you were comparing the mean value of one sample with standard value, right? Independent sample titers. How many samples were there? Two samples. Independent sample titers means two samples. Paired sample titers. How many samples were there? Are you sure? One sample, but two time frames. Got that? Two time frames, before and after. But only one sample is there. Huh? In ANOVA, one-way ANOVA, there are more than two samples. Okay. Can you give any example of more than two samples? No? Race. Like in Malaysia, Malay, Chinese, Indian, others. 4 races. More than two samples, right? So you can use that. Occupational class. Professionals, government employees, private employees, self-employees, and unemployed. Okay, 4 class. 4 class or 5 class? 4 class. Okay. Education also. Can you give different classes of occupation? Yeah, uneducated, maybe primary school, secondary, tertiary, and a professional. You are all going to be professionals, right? So like that. So when to use, what are the assumptions? Huh? Compare mean values of dependent numerical variable in more than 2 groups. Look at the diagram. Okay, sample 1, sample 2, sample 3. 3 samples are there. What is written? School 1, school 2, school 3. Okay, one school from Perak, one school from Selangor, one from Penang. Okay, 3 different schools. Okay, so there are 3 different samples. You want to know the mean value of one sample with another sample. Is it significantly different or not? Assumptions? Same for all parameters. What are the assumptions? Dependent variable should be numeric, and a dependent variable should be either interval or ratio scale. Understand? Then what else? Now, data collected from representative sample. There should be equality of variance. Equality of variance means group 1, group 2, group 3, variance should be equal. Okay. What is variance? Square of standard deviation. You look at variance in descriptive statistics, you will give it. Okay. This is the question. Compare the mean systolic blood pressure values among people from different departments. Okay, 4 departments are there. This is the data of an industry. Okay, 4 departments are there. So, I will show you how to do that. Okay. Systolic blood pressure in department. How many departments? 1, 2, 3, 4. 4 departments are there. So click on analyze. Compare means. You have to click on one-way ANOVA test. Okay. That is analysis of variance in multiple groups. That is ANOVA. Okay. Now select systolic blood pressure. Before click then. And you click department as the active. Okay, understood? So now you have to click on options. What are the options? No, here now you can give descriptive statistics, homogeneity of variance. That is one assumption. Homogeneity of variance means equality of variance, right? It's another name. Leibniz test of equality of variance, homogeneity of variance. Okay, that one you have to select. So descriptive you have to select, homogeneity of variance you have to select. Means plot. When you click means plot, mean value of different departments will be plotted as a diagram. So you can choose that. Okay. So these are the 3 things we chosen. Descriptive statistics, homogeneity of variance, and the means plot. Continue. Then click OK. Okay. So it will take some time, right? Yes. So ANOVA test, you have to look at the significance value. Significance value between groups. Okay. What is the significance value? 0.002. What it means? The difference in mean value in different groups, different department group is statistically significant. Okay. And another one. Okay, test of homogeneity of variance. Okay, you have to look at first one based on means. Okay, based on means, no, it shows 0.000. That means it is less than 0.05. So that means it is not, there is no equality of variance. Variance is different between multiple groups. So we cannot use ANOVA here. You have to use non-parametric test. Understood? That is one way you have to check assumption while doing the test. Got that? Equality of variance, Levene's test. You have to look at Levene's statistic. 0.000 means it is less than 0.05. So it is not, assumption is not satisfied. Okay? So then look at the means plot, how means plot are done. So that mean value of different departments, department 1 mean value, department 2 mean value, department 3 mean value, department 4 mean value. That one is plotted in a diagram. Understood? So these are the main things. Okay. Now, we understood that there is significant difference between departments. Each department is having a difference with which department. You want to know, right? Just saying that there is a mean systolic blood pressure in different departments is different. So you want to know which department is having significant difference with which department. Okay? So how to do that, you know? You have to click on this same step. Analyze, compare mean, one-way ANOVA test. Okay, click on that. Okay, we selected everything, right? There is one option, post hoc. Have you seen that? Post hoc. Post hoc test means to know the two-way comparison between the subgroups. There are 4 subgroups are there, right? So two-way comparison. 1 is to 2, 2 to 3, 3 to 4, 1 to 4. Like that. Understood? Two-way comparison can be done by doing post hoc test. When you click post hoc, it's so confusing. So many names. Which one to choose? Huh? 2 key. Yeah, so you please remember two-way comparison, right? So you select 2 key. T-U-K-E-Y. Is there any name 2 key here? Anybody home? 2 key? Yes. Second row, second column. 2 key. Okay, all are related to 2. Second row, second column, 2 key. Scientist name. Another one scientist is there 2 key B. Don't select that. You select pure 2 key. Okay, understood. So we are selecting 2 key. T-U-K-E-Y. Then click continue. Oh. Connect to charger. Okay, okay students. Is it clear?
Yes.
Now we selected 2 key test and we click continue. Okay, then click OK. So what is the finding? You are getting Levene's test of equality of homogeneity of variance. ANOVA test shows that there is significant difference between different departments. Look at 2 key test, that is multiple comparison. What is the finding in multiple comparison? between department 1 and department 2, there is significant difference. You know that? Between department 1 and department 2, there is significant difference because it is 0.033, less than 0.0. Okay, then what about others? Between department 2 and 1, it is significant. Okay, between department 3 and 2 and 3, 0.013, there is significant difference. But then between department 3 and 2, between department 3 and 4, there is significant difference. 0.023. Got that? Is it clear? Yes. Wonderful, right? This ANOVA we can do, and if you click two key comparison, you can know the significance between different subgroups. Okay, clear?
Yeah.
So we are nearing to the final part of this module. Yeah. Okay, this one. Yeah, now I will ask you questions. This is a favorite part of your training. Okay, now I will check. So 5 minutes is for question and answer. 5 minutes for learning log. 10 minutes for activity debriefing, then 10 minutes for assessment. Okay, so you know. Now I will ask you some questions. Compare mean with a standard value. Which test is used? One sample t-test. All of you agree with that, right? Okay, we are comparing the mean of a sample with a standard value. From where we are getting standard value? Maybe textbook or a guideline, something like that. List advantages in using parametric tests. What are the advantages? Can you tell one advantage, please? Huh? No bias. Yeah, there should not be any bias. Okay. But what is advantage means? What is the use when we are using? Huh? Yeah, we can generalize the finding with the population. Okay, so it is an inferential statistics. We are comparing the means, right? Means of different groups. One sample t-test, you already told. What about the independent sample t-test? Yeah, 2 samples. We are comparing the mean value of 2 samples. What about one-way ANOVA test? More than 2 samples. Okay, very good. Explain when one-way ANOVA test is used. More than 2 samples. Okay, very good. You are comparing more than 2 samples. Okay, then we will go to learning log. Okay. So this one, parametric statistical test. Okay, you already told, right? Can you tell any point that you didn't tell? Parametric test. Yes, please. Parametric test means what you understand? Yeah, we are inferring to the population. Okay. So what are the assumptions? What are the assumptions means in which condition you will apply parametric test?
Data is normally distributed.
Yeah, data is normally distributed. Then is
Sample size more than 30.
okay, very good. Sample size more than 30. Okay.
Equal variance.
Equal variance in different groups. Can you tell this? Just asking the test which is applied for equal variance. Do you remember the name of that test? Legumes test of equal variance. Okay, so you got full mark for that. Very good. One sample t-test. Can you tell anything about one sample t-test? You already mentioned comparing the sample mean with the standard value. Independent sample t-test you already mentioned. Paired sample t-test. Can you give an example of paired sample t-test? Yes.
One sample before and after.
Yeah, one sample before and after treatment or before and after an intervention or two different times. One time treatment is available, good treatment is available in government. Another time good treatment is not available in government. You can compare. Okay. Then, yeah, all the areas you answered well. Huh? Then, yeah, please.
For paired sample t-test, right? Can the example be BMI between male and female?
Independent sample t-test.
For paired sample t-test.
Paired sample we cannot between male and female.
Yeah, BMI between male and female.
One sample.
Then you were telling about paired sample t-test?
Yeah, is it correct?
No. Paired sample means one group can be a mix of male or female, but before and after. Maybe before a exercise program, what is a BMI? After exercise program, what is a BMI? You can compare. Okay, if male and female, comparing between male and female means it will be independent sample. Got that? Clear? Now we will go to assessment. Come. You have written name. Okay. We go to my here. Yeah. So, all of it got it done, right?
Yes.
Okay, guys. So, I hope our our module 1 and the module 5 finished. Okay, so thank you so much for your active participation. I really enjoyed your learning spirit and you are very good. Okay. 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 Then we can go to the last slide, please. Yeah, conclusion. Yeah, this then now you know how to observe the trend and apply various statistical tools and analyze the data so that you can improve your performance, process and outcome. Okay. These are the books. You please note down the books so you can read it. Many of the books are available online also. PDF version is available. Okay, thank you.
Thank you, sir. Sir, is there any more sessions after this? Dr. Sandheep?
Okay. Yes,
Do you have
please.
any more sessions after this? For our group?
This we can have during after your data collection we can have conversation, single session. Yeah.
Thank you.
Just now, right, the negative test was not significant. So then we cannot accept the test, right?
Yeah.
And then for this practice, we just assume.
Yeah, yeah. Here for this practice we used it, but in actual practice if limit test is showing less than 0.05, we have to go for non-parametric test. I told you, this data was manipulated one, so that's why we didn't get equal variance. Okay. But if you are collecting data from real population, unbiased sample, you may get better data. Okay.
And then the third test, one time we mentioned the 0.001.
Okay.
We said it's
Yeah, yeah.
less than 0.001, right?
Yeah, it is less than 0.001. Don't tell that p-value was 0. It is not possible. It will be some decimal lower than that. That's why 0.00001 or something. That's why SPSS will show only 3 decimal points.
Then if in the record, we write it less than 0.001 or
Yeah.
less than 0.001.
Less than 0.01 or 0.019. So, participants, please check this p-value. If it is less than 0.05, is considered as significant. If less than 0.01, is considered as highly significant. Okay, so you can, when you write a report, you can tell that highly significant. Okay, less than 0.01. Got that? Okay. Any doubts, you can contact through email or WhatsApp. Thank you.
Thank you, sir.
See you on Monday, sir.
Monday.
Tomorrow,
Tomorrow,
Friday.
nothing, right? No.
So next week is our last week in public, right?
yeah, we will be going to prepare.
Then there's no more
So you have to submit the research report and the notebook at the end of that week. That are properly reviewed that I when to submit. Okay.
because according to Dr. Kiran's timetable, we have until
26.
23 days.
23. Okay. Then you can can take that time for completion of your report and all. The relaxation. You have to submit your report. That will take only 2 days. Then you can submit your research report also. Okay.
Search and cannot sign out.
So, if our research not enough sample size, how? If our research not enough sample size.
Yeah, then you can modify the precision. If your precision is now 0.05, right? In the sample size calculation, you have put 0.05. So you can make it 10%. Then sample size will be reduced. Otherwise, you can show the same sample size and give us limitation. Okay.
So I have posted 10% for this one. Alright.
No, but this all about data analysis, right?
Oh, lucky lah.
You want these questions?
No.
Okay. Okay, guys. Thanks a lot. Huh? More towards your lectures and more towards your how to apply common sense. Not very difficult. That I'm not sure.
Oh, haven't decided. My question already been.
Okay.
Thank you.
Okay, thank you.
Thank you.
Thank you, doctor. Bye. Have a nice day.